Hi, welcome to week 28 of Algebra 1, and we are starting with this topic of factoring expressions. Okay, all right. And let me share with you what I've seen on the notes that I've received. I received notes from Caleb Manuel. Okay. Oh, this one, hold on, let me go to week 28 here. Great job. I love how you put in each step what you were doing. Okay, this is a very good strategy, Caleb, of taking notes and solving the problems. You write the equation and then you do what is the next step. Okay, that way, when you read it back afterwards, you will be able to clearly see what you have done. Okay. So yeah, it takes a little bit more of writing, but very good strategy for note taking. Ali, also I see your notes here, very good, very readable. Okay, following all the steps and everything. So excellent job in helping us understand your work. And Caleb, Gallagher also did a great job here. Let's admit everyone here on the notes. Also very clearly written. Okay. All the different steps for that. Okay. Also, I appreciate that he wrote here the titles of each one of the lessons as he took notes, and then the quiz. Okay. So great job with that. Okay. So thank you so much. And I really encourage all of you to turn in your notes. And if you turn them in late, let me know so I can go and look at them afterwards. Okay. The best way to letting me know is by sending me a chat message directly to me. Okay. I always see those. Sometimes I don't look at all the notifications. Okay. So those ones, because I have so many that those ones kind of get lost. All right. So for example, here I have Brianna just turning 6 minutes ago her notes. Okay. And so I haven't seen them yet. All right. But very good job with that. All right. Questions about this topic of factoring. I think that there is one question, one important question that is like hanging in the air. Okay. About factoring. And we are going to spend probably, the most of the rest of the time of the year doing these operations of factoring. Okay. So there's kind of something interesting. What would be the main question about it? Hmm. What would be the most important question to know about this exercise of factoring expressions? So we have these quadratic expressions and we are trying to factor them. Okay. I think that the most important question is like, why? What for? Okay. All right. So 3 years old students would have always been able to ask why. Okay, because they are always asking Why? Why? Okay. So it is interesting because as we grow up, as we grow older, we kind of suppress the asking of why in too many things. And that is unfortunate, really. Well, in this case, the why, the what for is actually very, very important and interesting for you to understand. Okay. So I'm going to tell you the why we do factoring, okay, before you actually are going to apply it in other parts, other areas of algebra and mathematics. But I think that is important so you understand why we are doing this, okay? And it has to do with geometry here, okay? It has to do with graphing things. Okay. Do you remember what I told you about quadratic equations? There's something interesting about quadratic equations. What shape do they describe when you graph a quadratic equation?
Isn't it a parabola?
Yeah, it is a parabola. That's right. Chiron, you are correct. Okay, so a quadratic equation describes a parabola. So let's take one quadratic equation. So we are going to put y equals x to the square. Okay, and there you already see the parabola. Okay, now we are going to put a linear term here. All right. Let's see, minus 3x, okay, and let's do minus 10, okay. So this is the parabola that this um, equation describes, okay. Now, let's factor this expression. Let's factor the expression. Okay, by what you have learned, all right, in this lesson, let's do the factoring of x squared, okay, x squared minus 3x minus 10. Okay, this is one that you have probably already done and that. What do we do to factor this expression? What are we trying to do? You
We
can look at
find
your notes, you can look at everything, okay, juggle your memory and so on.
we
So
find
let's see what we have.
two numbers that add through that equal 3 if you add them and multiply to 10. So yeah, a plus b equals 3 or negative 3, my bad, and a plus a times b equals negative 10.
Negative 10. Okay. All right. So what do you know when you have that this sign, okay, when this is negative? Okay, because we have to multiply, okay, two numbers and the result is negative. So what is going to give you that? When I
Isn't it a
multiply
positive?
two numbers. Yeah, go ahead, Glenn.
Isn't it a positive times a negative? I can't remember exactly how all those were.
Okay,
I think
so
it's
that is
positive.
that is fundamental. Okay, so if we do a positive times a negative, then we get a negative. Okay.
Yeah.
If we do a negative times a positive, we also get a negative.
Yep.
If we do a positive times a positive, we get what?
A positive.
A positive. Okay, and what about if we do a negative times a negative?
You get positive.
We get positive. Okay, yeah,
Yep.
all right. So we know now that in here, we need to have that either A or B is negative, one or the other, okay? All right, and then the sum of both have to give me -3, okay? The sum of both will need to give me -3 here, all right? And so let's think about what numbers would I get for that? Samuel?
-2 and 5.
All right, so let's see. If we do -2 times 5, that is going to give me -10, okay? How about now when we add, we do -2 plus +5. What do I get?
You get +3. It's a -5.
Okay, so I get the +3 here, all right? And so what I need to do is to change the signs here, all right? Okay, and so -5, so 2 times -5, it still gives me the -10. And then the 2 positive -5 gives me my -3 that I'm looking at. All right, Brigham?
Something that always helps me when I do it is, like, I know that since they're both negative, I mean, one of them is negative and one of them is positive, but the one where you add them together is negative, then the greater number is going to be negative.
Exactly, yes. Then the greater factor, okay, of these two is going to be the one that is negative. Okay. It's fine to give it kind of a trial and error, so no problem with that. Okay, so what is the factoring of this expression? Okay. So what do we end up with? We put a parenthesis, okay, and we say, okay, so this is x, okay, plus
-3.
Okay, so
Wait, no, yeah.
no,
No.
we have that A and B
No,
is
it's 2.
2 and
It's
minus
2,
5.
yeah. Thank you.
Mhm.
-2 x minus 5. That's what it was.
X minus 5. Okay, yeah. And so we can see that this is y, okay? So y is equal to that, and y is also equal to this, okay? Now I have basically reduced, I have factored the quadratic expression into two factors, okay? So see, this is multiplying one and the other, okay? So far, so good? Okay. Now, in a parabola, one of the interesting things about a parabola is to try to find where does the parabola cross the x-axis. These are called the roots of the parabola. Okay? This is one root of the parabola. This is the other root of the parabola. Okay? Yeah? Caleb?
And it's totally a coincidence that they cross at -2 and 5.
Is it coincidence? Not by a long shot. Okay. All right. Now, you know that when we are solving an equation and we want to find the x-intercept of an equation, okay, that means that y equals 0 here. Yeah? All right. You see that? Y equals 0, okay? And so what I want to do is to see, all right, what is going to make it so this y is 0, okay? So 0 is x plus 2 or x times x minus 5. Okay. So what is the way to get a multiplication that is going to give me 0? So if I multiply A times B, okay, or let me put other letters. So let's say that we put, K times G equals 0. What is going to make it so the multiplication of two numbers gives me 0?
One of them is 0.
One of them has to be 0. So it's either K is 0 times G, then that is going to equal 0, or K times 0 equals 0. Okay? Are we all right so far? Okay. And so in this expression, I have that it's either this factor is 0 or this factor is 0. And we are going to take each one a turn, all right? And so if I say the following, okay, I'm going to go over here, okay? I'm going to go over here. And so if I say 0 equals, okay, and then I'm going to say that x plus 2 is going to be 0, okay? What do I do in order to make x plus 2? What would be x plus 2 equals 0? What would be the value of x?
-2.
Negative 2. Okay, because negative 2 plus 2, yeah, that is going to give me the 0. All right? And so I have that one of my solutions is when x equals -2. How about if I take the other factor, okay, x minus 5, and we say, now let's suppose that this one is the one that equals 0. Okay, so what is going to be for 0 equals x minus 5? Okay.
It'd be positive 5 minus 5.
That's right. Positive 5, okay, is going to give me that. So this is the other solution, all right? And so now I can see that, yes, when x equals -2, then y equals 0. When x equals positive 5, okay, y equals 0. And I have the roots of my parabola. Okay. This is really, really cool. All right. So this is the why we are doing all this factoring. We are transforming a quadratic expression, a quadratic equation, into two factors that are going to help me find the roots of this parabola. All right. Give me a thumb meter on where we are with this. Okay. Yeah. Okay. So this is actually very important because, this is exactly what GeoGebra is doing in order to draw the parabola, is finding what are the roots of the parabola. Okay. Does that make sense? All right. Parabolas are very important because the trajectory of every projectile is a parabola. Okay. when you throw a ball, when you dive into the water from a cliff, okay? All right, you are describing a parabolic function, a curve, all right? And so that is a very, very important thing in physics to work and figure out how parabolas work, okay? Questions, comments about this? This is okay, all right, good. So let's do another one, okay? So let's do another one. I'm going to clear here the drawings. Okay. And I'm going to ask you to come up, okay, with a quadratic expression, a quadratic expression. It could be one that you have in the homework or something. All right. And then let's see who would like to tell one quadratic expression.
I can get one really fast.
Okay. Mhm.
X squared. Tell me when you want me to.
Y equals, so x
Squared.
square. Mhm.
Yeah, squared plus 5x minus 15.
Minus what?
Minus 15. 14. Minus 14.
Minus 14. Okay.
Yeah.
All right. So we have that there. Okay. Now I want you to find the roots. Okay. I hide it. All right. I hide it on purpose. Okay. So now let's factor this. Let's factor this and make sure that you find the roots of this parabola. Okay, so we have y equals x squared plus 5x minus 14. Mhm. Okay, everyone should be working on that. If you recognize this from your homework, you have it. Okay, that is fine too. All right.
Got it.
Mm-hmm.
It's 2 and negative 7.
So 2 and negative 7 are
Are the
the.
roots.
Hmm?
2 and negative 7 are the roots. I already had the problem done in my homework,
Uh-huh.
so I just went off the
Okay, so tell me how what would be the factorization of this first?
okay. X minus 2, X plus 7.
X plus 7. Okay, and so my roots, like you say, are x is 2 and x
Is 7.
equals 7 minus 7.
Yeah.
Okay, so those would be the roots of this. Okay, of this parabola.
Yep.
All right, Vincent.
Would it be -2 and 7 since it's a +5?
So let's see. So it is positive, okay, and so we have that 7, okay. So 7 minus 2 gives me the 5. Okay. All
Oh,
right.
that you. Oh, sorry, I misheard you. I thought you put something else.
Yeah, that's right. So let's not get confused between the factorization. So this is the expression that factors, okay, that's the factorization of the quadratic. And then from there we get the roots. The roots are the opposite, the opposite of these numbers. Okay.
Okay.
All right. Mm-hmm. Sounds good?
Yeah.
All right. So now let's go ahead and show it and see. Voila, -7 and 2. Okay. What would be the other interesting thing to find out in a parabola? What would be the other interesting thing to find out in a parabola? Kyron?
It's vertex.
The vertex, yes. Uh-huh. Yeah, so we would like to really find out, okay, what is the vertex of these parabolas? The vertex is this point here, okay? So, so we have that this would be the vertex of this one, all right? And this is the vertex of that parabola, okay? Yeah. How do we go about it? We have the roots. So the roots can be helpful, okay? What can we do now?
Would you
What can
multiply
we,
them together?
hmm?
Would you multiply your roots together or something like that?
Let's see. So if I multiply the roots together, it's going to give me, like in this case, okay, 2 times minus 7 is going to give me minus 14, which is this number there back again, okay?
Yeah, that wouldn't work.
Yeah. What do you notice? Okay, so let's see if you notice this on the okay, let me see. Let me move this back to this. Okay, so this is where we had the vertex. Okay, and let's annotate this. Sorry. Let's move this a little bit up so we can see the x-axis. Okay. So if I go, there. If I go over here, keep going up, okay. This is where the vertex of this one is. This is where the vertex of this one is. What do you notice? Let's see, this one would be the vertex of the blue, and this is kind of the x of the vertex of the green. Let's try to concentrate on finding the x, okay? So here I have, the x point, okay, the x value of the vertex, okay? Caleb?
So I found that since it's going straight up, that the x value of the vertex will be halfway in between the roots. So to find halfway between the roots, I just add them together and divided it by 2.
Wow, yeah, uh-huh. Excellent. So the parabola is symmetrical. Yeah, so both sides are exactly the same. All right. And so the vertex is going to be halfway exactly between the two roots. Okay. And so let's do what Caleb suggests and see what we get. So we have that one root is minus 7, the other root is 2, okay? So what do we do? Okay,
Add them together.
we add them together. So we have minus 7 plus 2. Okay, that is going to give me minus 5. Okay. And then halfway point, I'm going to divide this by 2. Okay.
Negative 2, negative 2.5.
Negative 2.5. And voila, that is where I have that. Okay. Isn't that cool? Yeah. Kyron?
So, is the vertex different than the extremum? Because I noticed that the extremum works on a parabola because it's a function. So is the extremum different than the vertex?
So the
That's the
word
point.
extremum is applied, to functions. Okay, so functions could be this way. Okay, so they could have different, shapes like this. All right, and so each one of these would be considered an extreme point. Okay, all right, does that make sense? In the parabola,
Yeah,
we have just one of those, and then we call that the vertex of the
mm,
parabola. Mhm.
I wonder why GeoGebra says select a function. I select the parabola, and it marks it as that.
For GeoGebra, everything is a function. Okay, so it is a function. A parabola is a function. Okay, and so here GeoGebra is just generalizing the values. All right. Okay, so the vertex is an extremum of the parabola function. Mhm. It just happens that the parabola has only one. Okay. All right. Okay, so now we have the x value of the vertex. How do we go about finding the y value of the vertex?
It's in the
We need to now
equation.
find.
It's
Yeah, go.
it's b in the equation. So negative 14 is this one, and negative 10 is the first one.
So
And you can
14 minus 14 is
yeah.
the y-intercept.
Oh wait,
Okay,
never mind.
y-intercept. Always,
hmm Sorry, I must have misheard you. That's what I thought you were talking about.
yeah. No, this is good because in this equation, if x equals 0, then this is 0. This is 0. 5 times x is 0. Okay, and so I end up with just y equals minus 14. All right. So the constant term is always the y-intercept in here. Okay. How about if I replace 2.5 in either this equation or this equation because they are the same. Okay. Yeah. Which one do you want to do it in?
Wait, replace what exactly?
2.5. I need to find, okay, when x equals 2 minus 2.5, I need to find the y. Okay. In order to find the y value there of the vertex that is off the screen here.
Hmm.
Yeah. So let's use this one here. So I'm going to replace wherever it says x, I'm going to replace it with minus 2.5. Okay, so minus 2.5 minus 2 and then minus 2.5 plus 7. Oops. Okay, talk to me. What do we have here?
Negative 4.5.
Negative 4.5 times, okay, this is a times. Oh,
um,
is it negative? Sorry. So, yeah, this is negative. Okay, yeah, we have a negative. Times what?
Positive,
4.5.
yeah, 4.5.
Hmm?
Positive 4.5.
4.5. Okay, all right. So now we multiply these two numbers. Okay, it's going to be negative. The result is going to be negative. Okay. And then I do 4.5 times 4.5. Okay. So 5.5 is 25. This is 20 plus 2 is 22. Okay. 20, also 2 there, 16, so 18. Okay. Check me if I'm doing this correctly. Okay. Does that look okay? All right. So there we have 20. So the y-axis, the y is going to be 20 minus, sorry, it's going to be minus 20.25. Okay, 20 and 1/4. All right, let's look at this and see if I'm okay or what. Right there. Okay. 20 and 1/4, minus 20 and 1/4. Mm-hmm. Is that fun or what?
That is cool.
This is really, really cool. Okay. And this is why you are doing factoring of a quadratic equations, is because they describe parabolas, and the parabolas are, what we are going to be using in physics and in calculus and a bunch of expressions. They are very, very useful. Okay. So we are talking about the war in the chat. What is going on? Caleb, give us the news. You are dating the video now, because now it's like, okay, yeah, this video is this day. All right. Now, let's do this. I'm going to ask you to analytically, all right, using your smarts and the things that you know now, to find the vertex here of the green, okay, equation. Okay. Find the vertex there of the green equation. You see it there, but I want you to actually calculate it analytically. Okay. So we have the roots. Okay. And so let's go ahead and apply what we know to do that. Okay. Hi, Taxon. Ethan, turn the camera on, please. Okay. So let's see if we can do, let's share again and show what is the equation here. So it's y equals x squared minus 3x minus 10. Okay. And so I want you to find, we found the roots. I want you now to find the vertex of this parabola. Okay. Using what you now know and learn about this. Okay. 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 Who has it? And show me what you have. Or tell me what you found. Okay.
Okay, so so it was -2 and 5 was the root.
Uh-huh. Yeah. So the roots were -2 and +5. Okay.
Okay, so then it's 3. So then you add those two together and you get 3, and then you divide by 2. So it's 1.5 is the x.
Mm-hmm. 1.5 would be the x. Okay. Mm-hmm.
Yes. And then let's put it into the equation. So it would be 1.5 squared minus 3 times 1.5 minus 10.
Mm-hmm.
And then 1.5 squared is 2.25. And then minus 4, and then it's minus 4.5.
Mm-hmm. So we have minus 14.5. Okay. And then 2.25. Okay. Mm-hmm. This is going to give me negative
12.25.
12.25. Okay. So that would be my vertex. Okay. 12 negative 12.25. Okay. 12 and a quarter. Okay. So this is the vertex. Okay. Of that. And if I show that, yep, there we go. 12 and a quarter and 1.5 is the point. Okay. Good. Now give me a thumb meter on this. Are we okay with all this? Yeah. All right. Now let's play a little bit here with the signs. Okay, so let me clear the drawings. All right. And let's see. What happens if I change this minus to a plus? Okay. All right. Huh. Here we are going to see now the parabola. Okay. The parabola is still going to be a parabola, but this is where I have these imaginary roots. Okay. Because the roots are now not crossing the axis. Okay. These are the -2 and the 5 right there, but they are not crossing the x-axis. All right. That is what we call an imaginary root. The vertex is now translated. The vertex is still at 1.5. Okay. But now it's up. The constant term plus 10 is the y-intercept here. Okay. And I have that the parabola is still going up. Okay, that way. How about if I change this to a plus? Okay. So now we have that. Okay. So now I'm going to move the linear term moves the parabola linearly. Okay. That is kind of what is doing. All right. what about if I put the quadratic term as negative? What is going to happen now? Okay, now we go the other way. All right. Okay. So when you use parabolas in physics in order to describe the trajectory of projectiles and things, you are almost always going to have a parabola going down. All right. And so the quadratic term is negative. That is what makes that. Okay. So frowny face. Okay. A negative quadratic term. All right. Good. All right. So have we beaten this horse quite well there? All right. Okay. So that is the why we do factorization. So I'm going to make week 29 visible for you. And we have different techniques of factoring quadratic equations. And so that is the challenge here is to learn and see all the different strategies and ways of doing the factoring. Okay. So we are going to be doing a lot of different techniques. Here we are going to introduce you the factoring quadratics with perfect squares. And we'll see what that means. And it is a very important way of looking at factoring. Okay. Tyron?
Are you opened week 29? Are you ending this now? Is this going to be the shortest well-educated hard academy class in the history of well-educated hard academy, except for that one algebra class that you did that was 60 minutes long because you forgot to start the recording? Or is there something else?
Let's see.
Either one would be fine with me.
Either way is going to be fine. Okay.
Because you have the shortest class ever, or you have more fun stuff with parabolas.
Uh-huh. Okay. So I don't have more fun stuff with parabolas, okay? I just wanted to give you kind of a heads up on this issue of the parabolas, all right? But let's go ahead and do some more fun stuff with parabolas and with factoring and quadratics and so on, okay? So let's go and see here in week 28. Let's go and look at the quiz. See what the quiz gives us and see if we can draw the parabolas that are here in the quiz. Okay. So I'm going to start this. Okay. And so here we have this expression. All right. So let's factor this one. Let's factor this one. And what do we get? Okay. What would be the factorization of this one?
I think it's B. Oh, sorry, no, it's A.
A. Okay, because we are not factoring the x square out because the other term, the constant term, doesn't have an x. Okay, so we are going to just find a factor right there. Okay.
You can see the x squared on the top of it, and I was just like, oh.
Yeah. Okay.
I've made that mistake one too many times.
One too many times. All right, on this. So let's try to describe this parabola. Okay. So is this parabola going to be a smiley face or frowny face? Is it going to go
Smiley
up?
face.
Okay.
Smiley face.
A smiley face. Okay, so we are going to end up with something that is a smiley face. How do you know that?
Because it's not a negative in front of the x squared.
That's right. Okay, so the quadratic term is not negative. All right. So now let's see, how do we find our roots? Okay, when we have this case, we have to find our roots. Okay, so we are basically saying the equation here of my parabola is y equals 4 times 3x squared plus 2. Okay, and the roots are going to be when? When am I going to find my roots?
When when y equals 0.
When y equals 0. Okay, so I have to, basically solve this way. Okay. All right. What do I do next? I want to find the value of y. Okay, I'm going to end up with that. So what do I do next in order to isolate x by itself? Leave x by itself.
Add 3 to that side. No. Subtract 3 from both sides.
Not yet. I have a factor here. Okay, so we have two factors. Okay, and then within the second factor, I have two terms. So first, I need to
So multiply,
remove this factor.
do distributive property. 4 times 3 and 4 times 2.
Okay, so I could go back to my original 12x squared plus 8. Okay, that is this one here. Yeah. What do I do now? I have now two terms.
Now, could you subtract 12 from both sides?
Not yet. Okay, I need to subtract
Oh,
something, but what is it that I need to subtract?
the exponent, right?
Not
But
yet.
You
no.
need to subtract the 8.
Yeah, I need to subtract the 8 from both sides. Okay. All right. So minus 8. All right. So I'm going to have minus 8 equals 12x squared.
Got it.
Got
Okay.
it? Okay. Now what do I do?
Now you subtract the 12 from both sides.
Subtract or what?
Divide.
Yep, thank you.
Yeah, now we divide, okay, both sides by 12. All right. So this cancels that. All right. Okay. And so this is going to say that x squared is a
Negative
minus,
2/3.
okay, minus 2/3. Okay.
Okay.
Yeah. Now how do I find the value of x? Because this is minus 2/3 is the value of x squared. Okay.
It's broken. You can't square root a negative number.
No, this is going to give me imaginary roots, but we are still okay with imaginary roots. Okay. That is no problem. But I need to basically find the square root of both numbers. Okay. Yeah. So this is going to be, okay, we kind of already talked about this, but so we have x because this cancels that. All right. So the x is going to be the square root of 2/3 2/3 times I. I is the imaginary number. Okay. Yeah. So that is going to be, so basically this is like saying 2/3 times -1. Okay. Times -1. So now I can say, oh, okay, this is the square root of 2/3, the square root of 2/3 I equals X. Okay. Let's bring our calculator here and get the value of the square root of 2/3. Oops. Come on. What happens here? Come on, calculator. Okay. All right. So I'm going to put here, so it's 2 divided 3 square root. Okay. 1.73. Okay. 1.732. So no problem. This is okay. All right. And so this is going to be, okay, let's annotate again. This is going to be that X equals plus or minus 1.732 I. Okay. Remember that the square root of a number can be either positive or negative. So that is why we have plus or minus. Okay. So the root is going to be somewhere, okay, on the imaginary plane, but is going to cut, okay, at minus 1.73 at a plus 1.73. Okay. Now let's find the vertex of this. Let's find the vertex of this. Where is the vertex going to be? Remember that we add those together and then divide by 2. Okay. What happens when I add minus 1.73 plus 1.73?
It's 0.
It's 0, yeah. And 0 divided by 2 is 0. Okay, so I know that the vertex is 0, comma something. Okay. Yeah. Okay. Let's find out what is that something. So now we are going to have, need to replace what is going to be the value of y in this equation. Okay, I can do it in here. Okay, so y is equal to 12 times 0 to the square plus 8. Okay.
Plus 8 or 3?
Plus 8.
Okay.
Yeah, I wrote half of 8. Yeah, 8 divided by 2 is 3. Yeah? No. Okay. All right, so what do we have now?
Well, 12 times 0 squared. 0 squared is just 0
0
plus
squared
nothing.
is 0.
So it'll just be 12 times 0 plus 8.
What is 12 times 0?
0. And then
0. Okay.
you just have 8.
And then I have 8. So y equals 8. Okay. Which is not surprising because that is the y-intercept. Okay. That is the y-intercept. Okay. And so I'm
Which
going to
means
have that my parabola is going to be somewhere in here. Okay. It's going to be somewhere in here.
oh wow. GeoGebra was
Okay.
right after all.
Yeah.
I
So
was
it's going
confused
to
because I
be,
was
this
like,
is 8. Okay. This is 8. And it's going to be, a smiley face going up. The roots are not going to cross the x-axis because they are imaginary roots. All right. So we have the I there. I can find out where they are going to be in here. I could do that also, but that is kind of how it goes. Okay. Sounds good? Okay. So there we go. Let me clear all the drawings. I hope that you have been taking notes and, writing things down of this, because this was like, okay, pretty interesting, pretty good. Okay, don't be afraid of quadratic equations, of parabolas. Now you know how to describe them and everything. All right. I invite you to apply what you are learning now as you do these exercises. Okay. As you do the exercises and you find, oh, this is a quadratic equation. I wonder what the parabola is going to look like. Go for it. Do it. You are going to gain a lot more insights about factorization and why you are doing this as you practice also doing the parabolas and analytically finding out where they are. Okay. Yeah. All right. Questions, comments, smart remarks?
I have a comment.
Yeah.
I was doing algebra and my ADHD brain, I was doing algebra this morning. My ADHD brain said, why do platypuses even exist? And I thought about evolution and platypuses for like 5 minutes until I got back on track.
So 5 minutes of platypus thinking, okay, in between algebra. Okay.
Yeah, it was
Yeah.
really weird.
What is the trajectory of a platypus if you throw it up? Okay.
A parabola,
It's going to be a parabola. Yes. All
which we talked
right.
about in earth science because of the curvature of the earth, you're going to throw it and then the ball curves up and then goes back down.
That's right.
Because
Yes.
yeah, although it was kind of a parabola because it was actually a ellipse, but for us it looked like a parabola.
That's right. It's the top part of an ellipse, which will be really like a parabola for us. Okay. So fantastic. So there you have the connection between the quadratic equations and platypuses. When you throw platypuses up, they are going to describe a parabola in their trajectory.
Yeah.
Fantastic.
But
Okay.
still, why? Like, that is what is one of the most random creatures on Earth.
It is really. It is really. And, I've heard that the platypus was a an animal designed by committee. Okay, we wanted a little bit like a bird, and like a mammal, and a marsupial, and kind of mix all that together, and we get a platypus. All right. So amazing. All right, well, let me stop the recording. Caleb, give us the latest